Hi everyone, my name is Sofia Pinto. I'm a PhD student from Portugal currently working on the gut microbiome and gut-brain axis. Today I want to talk to you about dietary assessment in gut microbiome research. So not the statistical part, not the analytical part, but the diet part. And as you all know, this is a key modulator of gut microbiome. So it's really important to take this into consideration in the gut microbiome research. So, why is measuring diet so difficult yet so important? It's a high dimensional variable. We have hundreds of foods prepared in different ways, different nutrients and patterns that we want to capture, but they can also shift daily and different life stages, and one snapshot rarely tells us the full story. It's also culturally embedded, which means different preparations, timing, and contexts, which can vary across populations, and which makes it hard to standardize in different regions. And it's also a self-reported variable. We often ask participants to recall and to tell us what they are eating, and this brings this recall bias, social desirability bias, and obviously we are estimating the portion sizes, which also has associated errors. So diet is simultaneously the most important and the most error-prone variable in microbiome research. And to make this simpler, I try to divide it into three main roles that diet can play in your research study. The first one is diet as an exposure, and this is the focus of your study. So you are trying to measure the direct effect of diet in microbiome composition or function. For example, if your research question is, does high fiber intake increase bacterial diversity? So diet here is your exposure. Then we have diet as a confounder. So diet is distorting the signal that you are measuring and not the focus of your study, but correlates with your main exposure, creating this or might create this masked association with the microbiome. For instance, if you are studying geography and its effects on microbiome, the different diets that are in different regions can affect or distort or confound this association. And then lastly, the modulating effect of diet. And this is the most interesting and most exciting aspect. So diet can shape the response that you are trying to measure. It can change how strongly or in what direction an exposure is affecting the microbiome. Here, if you are trying to see if Mediterranean diet can amplify the microbiome response to a probiotic, so here a probiotic will be your exposure and the microbiome your outcome, and obviously diet here is modulating this response. And after choosing or defining the role that diet will take in your study, it's important to choose the right assessment tool. There are different tools that you can use, and it will depend on the effect of diet in your study. So the food frequency questionnaires, they're really commonly used in epidemiology studies, and it's because it measures the habitual diet that participants will have during months or even for years. But its main limitation is that it cannot quantify the absolute amount of nutrients. And if that is what you are trying to measure, these questionnaires will not be able to do so. So they are best used for exposure studies. So you want to reach a number of different participants, but the depth of detail that the data will not be so detailed. Then the 24 hours recall, this will give you this accuracy of intakes, of nutrient intakes, but it gives a high burden to the participants. So it's usually used for population exposure studies. But as we saw before, the variation and variability of diet means that one recall might not be able to capture this variability. And then we have the food diaries. These are records that the participants are registering everything they eat and drink for the number of days that you define. And this is the most detailed and accurate tool that we have. But will on the downside, we'll have a worse compliance for participants, and also that the recording of their behaviors can change, and so we cannot capture, or we might not be able to capture their habitual behaviors. This is usually used for, and it's best used for, short-term interventions. For example, if you are doing a probiotic trial, and you should do it repeatedly over time. And then finally, the biomarkers, which obviously surpass this limitation of the recall bias, but since they are specific to one nutrient and they're quite expensive, they're usually used for validation of this self-reported instrument. But the rule of thumb here is the more central diet is to your research question, the richer the tool required and the most depth of detail you need to assess it. Alongside collecting dietary intake, you should consider specific aspects. For example, the timing and the season. So diet shifts seasonally and around illness. And the record, the most important thing is that the assessment date should be aligned with the microbiome sample collection date. And I will talk about this in more detail, but this is an important aspect to take in mind. Also, the context of the meal. So we know that in restaurants, the portion sizes are different than in home-cooked meals, the different occasions, the alcohol consumption. So this will affect the estimation of nutrients. And then the nutritional supplements as well. Different vitamins, probiotics, omega-3s can modulate the microbiome independently of diet, and we should take this into consideration when we are measuring dietary intake. As I mentioned, this critical timing rule, so it's important to align the microbiome sampling window with the dietary assessment window. Here, an example: if you administer a food frequency questionnaire 3 months before stool collection, you are not measuring the diet that shaped the microbiome that you are collecting. So the best suggestion here is to collect dietary intake 1 to 4 weeks within the stool sample collection. And even better if you can repeat these measures over time. After collecting this data, you have a lot of metadata that you will need to process. And the first step is to choose the database that you are using. You have the USDA database that is the most commonly used, but you have also these different local databases. Here I brought an example for the UK database. And this choice will affect the nutrient values that you will get, and you should justify your choice. Then an important aspect that I find that most studies overlooked is the importance of energy adjustment. So to remove the variation that the food volume gives to the nutrient intake rather than the nutrient density that you want to measure. So the diet quality is not the amount of food that you eat, but the specific nutrients that you eat, adjusting for the energy and the calories that you eat. And then these individual nutrients are highly intercorrelated. This means that they will have high collinearity, and to reduce this, you have to then first use machine learning approaches such as the PCA, or you can even use these indexes that are published, such as Dietary Inflammatory Index, and use these patterns to link to the microbiome data, not the nutrients in itself. Then, and finally, an important aspect that we've talked about is the missing data. So this is a high burden variable, and we'll have a lot of missings that you can either input or exclude from your analysis, but this should be documented and have specified rules before the study begins. Regardless of which role diet plays, you must always consider these key confounders. So you have host factors such as BMI, age, and sex that will here affect the microbiome, as well as lifestyle factors, physical activity, smoking, and alcohol consumption. And obviously, the sequencing methodology will also affect the microbiome results that you'll get. and as well as the different dietary methods that will give different errors. But you always have to keep this in mind, that the most important thing is that the residual confounding from not measuring or under measuring diet is, in my opinion, the most underappreciated source of bias in microbiome studies. And then I give you here some points about analytical suggestions. And this is based on my experience, but obviously there are other options. So if diet is your exposure and the central focus of your study, you should, as we talked about, reduce it to patterns and then modeling in the different methodologies as per Manova that we have. If diet is your confounder, so you can include it in as covariates in regression models and then use sensitivity analysis to compare the models. And if diet is your modulator, you can add this interaction term to the statistical model or stratify your sample by diet, tertiles or quartiles, and then compare its effect sizes. So to end, 5 take-home message. The first one is to decide the role of diet before starting the study. It will determine your tool, the collection depth you will need, and the analysis strategy. Then this alignment of dietary assessment and microbiome sampling, because the mismatch of these can destroy the validity of your study. In the analysis part, to reduce the dietary data to patterns, and because this is really important, because nutrients are highly collinear and underpowered in its individual form. Then residual confounding from undermeasured diet or not measured diet is the most underappreciated bias in microbiome research, and you should always include it in your design study. And then finally, I think the key message here is that dietary assessment must not be an afterthought. It will determine what question you can actually answer about the microbiome and what about your study. Thank you so much for your attention, and I really enjoyed. And I left here my email contact. If you have any questions, I will be glad to discuss it with you. And I also want to thank the UK GIBA Network for bringing this important topic to discussion.